Hello everyone, hope you are doing well. I am Professor Dr. S.P. Nalawade. I am going to take a course on heating, ventilation, air conditioning and refrigeration. In this first session, we are going to study Introduction to Aircraft Refrigeration. The contents of this session are as follows. Initially, we will see the requirements of cooling in airplane. Then we will go to study why air cycle refrigeration system is used. And at the end we will elaborate the various types of airplane refrigeration system. So now begin with the requirement of aircraft refrigeration system or airplane cooling system. We are aware that aircrafts or airplanes cruises at an altitude of 10 km to 12 km over Earth's surface in a troposphere region. In this region, the pressure and temperature are very low. We are aware that as we go away from the Earth's surface, the pressure of atmospheric air go on decreasing, and it has been observed that in a troposphere region around 10 km height over Earth's surface, ambient pressure is 0.15 bar and ambient temperature is minus 50 degrees Celsius. So this air cannot be utilized directly inside the aircraft cabin because human being cannot survive in these conditions. Hence, we have to carry out the airplane cooling for human comfort. Then the following are the requirements of the cooling inside the airplane or aircraft. The common causes of this are as follows. Number 1, ramming action of the air. Number 2, solar radiation. Number 3, pressure of air inside the cabin. Number 4, control devices. And number 5, heat release from the occupants. Now we will see the ram effect. We are aware that the aircraft cruise in a troposphere region at a higher velocity of 1000 km per hour. At this velocity, atmospheric air will enter into the axial flow compressor section of the jet propulsion engine as shown in the figure. The inlet of the compressor consists of supersonic diffuser and subsonic diffuser. As ambient air enters into this diffuser section at such a high velocity, it has been observed that the kinetic energy of the air will go on reducing as it passes through the diffuser sections and it gets converted into pressure energy. Hence, the conversion of kinetic energy of ambient air entering into the compressor section into the pressure energy format is called as ram effect. This energy transformation is called as the ram effect. The another observation from the ram effect is elaborated here. We are aware that velocity is 1000 kmph, which is almost equal to 277 meters per second. It will cause the change in the enthalpy of air. It is formulated in this mathematical formulation. We are aware that change in enthalpy delta H is equal to ratio of square of velocity divided by 2. So if we try to compute that change in enthalpy, we can summarize it as product of specific heat of air at constant pressure and rise in temperature of the air. The product of this Cp and delta T is equal to half of the square of the velocity at which aircraft is cruising. So if we use this velocity 277 meters per second and specific heat of air 1005 joule per kg Kelvin, then we observe that change in the temperature due to the ramming action is equal to 31 degrees Celsius. So at this temperature, air is entering into the compressor section. It will also cause the skin friction over the inner and the outer surface of the aircraft, which will cause the heat conduction into the cabin of the aircraft. Hence, we have to conduct aircraft cooling. The another cause to consider the aircraft cooling process is solar radiation. We are aware that ultraviolet and other radiations are filtered by Earth's atmosphere, and less than half of the radiation present at the outer atmosphere in a troposphere region reaches to the Earth's surface at sea level. The intensity of solar radiation falling on the Earth's surface is almost in the range of 700 to 800 watts per meter square, whereas at an higher altitude, over 10 km height over the Earth's surface in a troposphere region, the intensity of solar radiation is around 1500 watts per meter square. So we can assume that average solar radiation intensity falling on the aircraft is around 1000 watts per meter square. So it will cause the heat conduction inside the cabin. Then the another cause which conducts the heat inside the aircraft cabin is shown here. The electronic control devices and the auxiliary equipments present inside the aircraft cabin also releases the heat energy continuously inside the aircraft cabin. It will cause increase in the temperature inside the cabin air. Hence, we have to continuously pump out this heat to the outside atmosphere. So, we also need here the aircraft cooling. As well as, occupants sitting inside the aircraft cabin are continuously consuming this air through their regular breathing. We are aware that human beings will release the carbon monoxide through their breathing, as well as it will release the heat energy into that air. So it will also increases the temperature of air inside the cabin. Hence, we have to conduct the aircraft cooling process inside the cabin continuously for human comfort. Now, we will see why air cycle refrigeration system is used for aircraft refrigeration. The causes are listed here. The most important cause is that air is going to be utilized as a refrigerant which is available free of cost. It is environmentally begin, safe and non-toxic. Then air cycle refrigeration equipments are extremely reliable. Their maintenance cost is very less, and the system downtime of this cycle is very less. As well as the performance of an air cycle unit does not deteriorate as compared to that of vapor compression refrigeration unit when they operates away from the design point. The design point is nothing but a standard operating point which will give us the optimum performance in real life. Then when we operate the refrigeration cycle, an air cycle unit can also produce heat as a useful temperature. This heat energy can be also employed to conduct the remaining other processes inside an aircraft. If this system is used together with the cooling, then highly efficient low energy processes are also possible. Now we will see the advantages of air cycle cooling system for airplane refrigeration. Number one, the air is used as a refrigerant, so there is no cost. Then it is quite cheap to use. Then we are aware that aircrafts are driven by gas turbine propulsion engines which consist of main compressor. Hence, that same compressor can be employed to conduct the compression process to raise the pressure of air from 0.15 bar to atmospheric pressure level 1.01 bar. So, hence, other auxiliary or secondary compressor is not required. Then, chilled air is readily available for cooling at a higher elevation. Then, the pressure range within which that air cooling system operates ranges from 1 bar to 6 bar. Whereas, if we try to use vapor compression refrigeration system, then lower pressure will remain 1 bar, whereas the higher pressure is in the range of 15 to 20 bar, which will make system bulky. Then, air is non-toxic and non-flammable. And finally, refrigeration system is light in weight. Hence, air cycle system is used for airplane refrigeration. As well as there are the certain disadvantages of air cycle refrigeration system. The coefficient of performance of this air cycle system is very less. because large mass of refrigerant is required to produce desired cooling effect, which will make coefficient of performance considerably less as compared to vapor compression refrigeration system. Then sensible heating of the refrigerant will take place in the cabin as well as in the exhaust side of the aircraft. Whereas in vapor compression refrigeration system, we observe that the refrigerant will continuously undergo phase change in condenser and evaporator, due to which only latent heat will come into the play. Whereas in aircraft air cycle refrigeration system, the sensible heating of the refrigerant is observed, which is the main cause of change in the temperature of the air. Then we are aware that atmospheric air contains water vapor, and there is possibility that this water vapor may get frozen at the higher elevation due to extremely low temperature, and it may affect the flow of the air, and finally it will affect the performance of air cycle refrigeration system. Now we will see the various types of airplane refrigeration system. There are the four main types of airplane refrigeration system as shown here. First one is a simple air cooling system, which will employ the gas turbine propulsion engine along with the heat exchanger device. Then second one is a bootstrap refrigeration system, which will involve the compression process in more than one stage. Then third one is a regenerative air cooling system, and last one is a reduced ambient system. So in this session we saw the introduction to the airplane refrigeration system. In the next session we will start with the detailed study of various types of airplane refrigeration system. Thank you.